Hello, my 7th graders. We have been working on the number system in math class, and you've learned all about rational numbers for a while now. Hopefully you're starting to really thoroughly feel like you understand at a secondary level what rational numbers are, how their different forms work together, and we're going to use those different forms to help us with some more calculations. To get us started on this, I need you all to get out page 13. Looks like this. It's called the drill rig task. Page 13, pen or pencil in hand, and be ready to go. First, I am going to read to you what this paper says. Up in the corner, it says drill rig task. This is a picture of a drill rig, and that's an oil drill. It digs into the earth to find oil. I don't know if you knew that that's where oil comes from, but it comes from in the earth. So it says right here, so does water. This one's talking about a water well. A water well drilling rig has dug to a height of -5 feet after 1 full hour of continuous use. So you can think for a minute about why that would have a negative label on it and what's going on there with the drill rig. You are only going to focus on questions 1 and 2. I'm going to read them to you, and then you're going to pause the video and give them a try in whatever way makes sense to you. Question number 1 says, assuming the rig drilled at a constant rate, meaning it keeps doing the same thing hour after hour, what was the height of the drill after 1 full day? This is the tricky part here on this, is it says justify your answer in 2 different ways. Some people like to put a line down the middle here so that they remember, I have to show this one way, and then I also have to show this a second way, okay? 2 different ways. And then after you finish that, question number 2, if the rig has been running constantly and is currently at a height of -300 feet, how many hours has it been running? So question number 1 is asking you, if you know the hours, how far will it be? And question number 2 is asking you, if you know how far it is, how many hours has it been running? So you're going to pause me right now and just try 1 and 2. Go ahead, pause. Ta-da! Let's check it out. One of the first things I often see students do, if you're doing this in class, I say, okay, everybody try this, however it makes sense to you, and I'd start walking around, I almost always see someone at least start some kind of visual like this. And the visuals are very, very helpful for us to see what's going on. This tells me we understand that it's -5 feet because 0 would be the ground level, and this water well drilling rig is drilling into the ground. So we've assigned that as a negative to show that we are below ground level. So we'd go -5 feet in 1 hour, -10 in 2 hours, -15 in 3 hours, and people sometimes quit in the middle of this because they realize 1 full day is 24 hours. So to mark that all the way down to 24 is a lot. Some people don't necessarily quit. Sometimes they just go, oh, that was 4 hours, and 4 times 6 is 24 hours. So maybe I can just do -5 times, well, how far did I get? -20? Whoops, maybe I could do, I'm at -26 more times. And some people stop and do a multiplication thing there, which is brilliant. It's a great idea. A lot of people recognize right away that if this is the visual that's happening, if I'm digging 5 feet every hour and it's 24 hours, then I can jump right to a multiplication problem. And I wrote this multiple ways. You can write it down multiple ways on your paper as well so that you show yourself these all mean the same thing. If I put a -5 next to the 24, right next to the parentheses with no plus or minus symbol in the middle, I hope you know that that means multiplication. This also means multiplication. This is set up as a multiplication to show out in longhand that it is 120, but the question I want to ask you right now is, does the answer 120 make sense? And if you say no, I agree with you. Why? Oh, because the answer needs to be -120. No matter how I write it or set this up, this answer is a -120. I want your brain to process that for a minute. -5 times 24 is -120. Why does it have to be a negative? Because we are drilling into the ground, and we are still every hour just going farther and farther into the ground, so our value needs to be negative. Now likewise, This is, I see, one of 4 different division problems. The vast, vast majority of my students recognize that because this is going the other way, this is now a division problem. And this is where we start to recognize, hey, what's this next number system standard going to be about? Oh, multiplying and dividing. We learned all about adding and subtracting. Then we also learned about how to convert between a fraction and a decimal, which involves division. Now we just need to go back to, okay, if I have all these positives and negatives involved, I know how to add and subtract. Now I need to know how to multiply and divide. And this is our final standard of the number system strand. So here are the different division problems that I see students write down. And they might write them like that, or they might write them with the divide bar. And the question I have for you, I just want you to look over those for a minute and ask yourself, which one do you think is accurate for this scenario? Let's see. Oh, shoot, negative 300. Okay, so it's definitely not one of those. Okay, it's got to be one of these two. Which one makes sense in this scenario? Are we dividing by 5 feet, or are we dividing by negative 5 feet? This is drilling into the earth. That 5 is still negative, so guess what, you guys? This is the correct division problem. Now, perhaps the more important question for today is, what is the answer to that division problem? Well, it's supposed to be hours. Negative 300 divided by negative 5. Can hours even possibly be a negative answer? Would that even mean anything? It took negative hours? That doesn't make sense. You can't have negative time. So you know what else this tells me, and this is something we're going to investigate a lot more, is that this answer is positive 60 hours. Huh, 2 negatives, positive answer. That's interesting. We're going to find out what in the world's going on there. First, let's complete part 3, and I'm going to help you with this part, okay? It says fill in the tables to represent the situation. So as I move down here to part 3, look at this. If I know that it's been digging for 1 hour, that means I do 1 times negative 5 because it's still drilling at the consistent rate of negative 5 feet per hour. 5 hours would be 5 times negative 5. 10 hours would be 10 times negative 5, and so forth. I am multiplying by negative 5 every time you give me new hours because it's negative 5 feet drilled per hour. The answer to each of these, it makes sense for it to be a negative because it's a depth. So 1 hour is negative 5 feet. It's got to be negative because that's how we labeled it. It's going into the ground, underground level. Negative 25, negative 50, negative 60. Notice I'm just doing my normal multiplication and then making the answer negative. That's all. Okay. Now, also notice in this table here, there's all those answers we just got. This table is just going backwards. So this table is asking us, instead of to multiply, it's saying, okay, you already know the depth, get me back to the time. Oh, that's a division problem, right? So this expression is negative 5 divided by, now instead of multiplying by negative 5, we are going to divide by negative 5. Because it's still negative 5 feet per hour, we're just now going backwards. So we are using the inverse operation. Inverse of multiplication is division, and we're going to explore that a lot more in the next couple weeks. Negative 60 divided by negative 5, negative 150 divided by negative 5, and negative 500 divided by negative 5. And that, of course, takes us right back to, look all the way over here. It's going to take us back to these answers. 1 hour, 5 hours, 10 hours, 12 hours, 30 hours, and 100 hours. But the big important thing I want you to recognize here is a positive times a negative gave me a negative. But a negative and a negative gave me a positive. What? Why? Everybody right now, flip your paper over to page 14. We're going to do this one right now too, because this is where all this really important practice is going to come in. And before we come to the top here, I want you to all come down over here. So we're on page 14. Come over here to where it says questions/notes. And I just want to show you something really quickly, okay? So most students accept very quickly and very easily that if I'm doing something like -5 times 10, we accept, let's add a little note here, okay? This negative right here, we understand and have talked about it this way, but this -5 is just telling me that it is the opposite of 5. So it makes perfect sense to students when we say, okay, so -5 times 10, that answer is -50. I'm going to draw this arrow down here so I know that's where the answer is. Why? Well, because this negative says do 5 times 10, but then do the opposite of it. Okay? That's what a negative is it's telling me to do the opposite. And an opposite is the other side of the number line from 0. So 5 times 10 would be 50, but now this negative is saying do the opposite of 50. Oh, okay, -50. No big deal. We're fine with that. It's cool. We're great with that. Makes sense. But then as soon as I say this, I'm going to change colors here because people get a little thrown by this. As soon as I say -5 times -10, do you know what mistake my students always make? Do you know what your brain wants that to be? It really wants it to be 50, but it really wants it to be -50. But I'm here to tell you today that it's not. First of all, for this really important reason, in mathematics, can this situation end up with the same answer as that one? No, because if it did, why would I have 2 different setups for it? Here's the other reason you need to be very aware of. And I'm going to put equals here because I will, of course, put the answer down here. But we're going to label this. Now, this one is telling me to do the opposite. But you guys, this one is telling me to do the opposite again. If they're telling me to do the opposite and then do the opposite again, I'm jumping back and forth on the number line. So what this is saying is, it's saying, yes, do 5 times 10. And then it's saying, do the opposite. And then it's saying, do the opposite again, which brings us back to a positive. And that is strange for our 7th grade brains at first. But we're going to write it down. Let's everybody come back up to the top of the paper here, all the way back up here. And we are going to tell ourselves, we're going to write it down here, okay? The reason it becomes strange for our brains is because we're used to what it was all the last, 4 weeks of school. So let's refresh our memories on what we said before. This box right here is adding integers. Adding integers, different signs. It's been written on my board back here for ages, but different signs subtract. Same signs add. We're going to add more to that because we know there's more to that. Subtract and then take the sign of the one that goes, this is squishy, farther. We remember that. We worked with out of town the first few weeks. And this one, same signs add and keep the common sign. That's what we're used to. Those are the addition rules. So same signs add, keep the common sign. That means if you do a negative plus a negative, you're just putting together more negatives and your answer is of course still negative. That's why multiplying starts to confuse us a little bit. I'm going to tell you right now though, the multiplying rules are easier. You ready for this? That's it. That's all you need to know. Different signs, do the product and then make it negative. Because if you have different signs, you only have one part telling you to do the opposite, which is going to jump you to the negatives. If you have same signs, you now have two things. You have a double opposite. So that's going to take you negative and then right back to positive. All you have to remember is different signs, your answer is negative. Same signs, your answer is positive. Now this whole part right here says a bunch of stuff that unfortunately we can't do right now because it would make way too much movement in the classroom and get each other in each other's space. And we can't do it right now. So what I'm going to have you do is I'm actually going to take you through the first few of these. What color should I use? Let's make it bright green so that those stand out, okay? I'm gonna take you through these first two rows and I'm gonna say out loud the rules that I'm using in my brain, and then you're going to pause the video and you're gonna try the rest, and then don't forget to come back and check and make sure you got them right, okay? 12 plus 5 is addition. Same signs add, keep the common sign. 12 times 5 is multiplication. Multiply, same signs, positive product. That's it. They're both positive. The answer is positive. Addition, here we go. Different signs subtract, take the sign of the one that goes farther. You can't ever forget those addition rules, but you have to keep them separate in your brain. There's addition, and then there's multiplication. Keep them separate in your brain. Different signs subtract, take the sign of the one that goes farther. Ooh, we switched to multiplication. Can you all see that product sign there? So now I'm gonna close the door on the addition rules in my brain, and I'm gonna open the door on multiplication rules. Different signs, negative product. That's it, you guys, that's it. The tricky part here is keeping them separate. Addition, same signs add, keep the common sign. Different signs subtract, take the sign of the one that goes farther. Multiplication, same signs positive product, different signs negative product. The trick is just keeping them straight. I see addition right here. Same signs add, keep the common sign. Ooh, I see multiplication. Switch your brain over to multiplication rules. And until you get them memorized, just keep looking up here. Keep looking up there. Different signs, negative product. All right, you guys, pause the video. Try the rest of those, say the rules to yourself as you try them, and then don't forget to come back and see if you got them right. Okay, check it out. Same signs, positive product. Your brain doesn't like to accept that at first, but remember we're saying opposite and then opposite again, which takes us back to a positive. Same signs, positive product. Same signs, positive product. Different signs subtract, take the sign of the one that goes farther. That's a -6. It was a -4. And then I realized that didn't make any sense and I don't know what I was thinking. -6. Different signs, negative product. Do you see the difference in these answers when you just change that one little operation? Different signs subtract, take the sign of the one that goes farther. Where over here, different signs, negative product. That's it. This is adding 0, so it doesn't change. This is timesing 0, so the answer's 0. Different signs subtract, take the sign of the one that goes farther. Different signs, negative product. Different signs, negative product. Notice when it comes to multiplying, it does not matter which one goes farther from 0. All that does is make the opposite. Different signs negative, different signs negative. Same signs, positive product. Ooh, look at this, same signs add, keep the common sign. Again, just changing that one little operation changed your whole answer. Those are opposites, addition makes 0. Those are opposites when multiplying make -36. Different signs subtract, take the sign of one that goes farther. Different signs, the product is negative. Your math practice today mixes up multiplication and addition. Keep these notes out as you work on this. Get a piece of paper so you can write things down. Keep these notes out so that you can reference these rules on the top. Keep this out and keep looking at this. You got to practice moving between those two doorways in your brain. Am I adding? Same signs add, keep the common sign. Different signs subtract, sign one goes farther. Or am I multiplying? Different signs, negative product. Same signs, positive product. Let me know if you have any questions. You guys can do it.